So my name is Joe Palermo. I'm a research engineer at OpenAI. And today I'm going to talk about custom models research. So first, what do I mean by custom models? So with custom models, our goal is to use our research stack to do large-scale fine-tuning on behalf of customers in order to produce models that are radically better in specific domains. We look for customers that are working on very hard problems that push our models to their limits. With respect to fine-tuning, we focus on things that are not yet possible with our fine-tuning APIs. Things like initializing from base models, by which I mean models that haven't yet gone through post-training like RLHF. Large-scale fine-tuning, for example, on the order of. I'll pause for a moment while we sort out the slides.
Sorry, forget that.
So another example, something we do that's not yet possible with fine-tuning API, large-scale fine-tuning on the order of, for example, on the order of 10 billion or more training tokens, and also running custom RLHF. So why are we doing this? Firstly, there's enormous demand in the market for models that are significantly better in a given domain. Second, a significant fraction of the world's most valuable data and expertise is proprietary, especially in domains like healthcare. So in order to maximize the value we can deliver to the world, we have to find ways of leveraging more of this data. Another reason to do this is to provide inputs back into research, specifically to create challenging real-world evals, which aren't easily gameable. We also expect that the work that we do on the frontier of applications can help inform future iterations of our fine-tuning APIs. Now I'll talk through a case study. So last year we started a custom model project with Arize, which is a company I'm sure many of you have heard of. They build AI tools for law firms. And Harvey wanted to make progress on the problem of generating better answers to complex questions about case law. So here's a typical example question. In order to evaluate our progress, Harvey's team of legal experts created a set of such questions with gold standard answers. And these answers read a bit like essays. They're the order of 1,000 tokens or more, grounded by many citations into the underlying case law. And converting these answers into automated evals is non-trivial, which I will come back to later. I want to talk first briefly about why this is such a hard problem. This isn't a simple thing to fine-tune for, because writing these answers is a complex skill which is anchored to a large corpus of knowledge. It's not a simple matter of fine-tuning an output format or a behavior pattern. It's much deeper than that. One obvious thing to try here is retrieval augmentation, but in practice, this hasn't worked well yet on this class of problem. For one thing, the questions that interest Harvey in this case can't simply be looked up in a few places. They require deep knowledge integration. Few-shot prompting with expert demonstrations also only gets you so far. It may help a bit with the structure of an answer, but not as much in eliciting the obscure knowledge that's actually required to answer these questions. Also, expert demonstrations are very expensive to collect. So in practice, it turned out the most straightforward way to make tangible progress on this was to simply train on a very large corpus of case law and to attempt to get generalization downstream of that to the task that we really care about. So today, the paradigmatic way to train on a large data set like this is to extend the pre-training phase of the model, in this case with a much more relevant data mix. So in this case, we would give much higher weight to case law than we otherwise would. Model training is finished with a fairly standard RLHF process on top of that. Now, before I get to the results, I want to talk about evals. So one of the biggest bottlenecks on the frontier of applied AI today, as everybody knows, is model evaluation. It's also an area where creativity can go a long way. So in this case, since the model outputs are so large, evaluation was especially challenging. So one of the big advantages of working with a company like Harvey is they keep highly skilled legal experts on staff just to perform model evaluation. So human evals were very useful, but they're also very slow and expensive. What you really need when you're doing this kind of work is an automated eval that you can use to tell if you're making progress or not. And also to tell which two or more models that you've trained is actually better. And if you can't do that, then you really can't make progress. So one straightforward eval is simply compute the perplexity of expert answers, but there is no substitute for actually sampling an entire output from your model and somehow evaluating how good it is. We eventually made the discovery that we could leverage the presence of citations from answers and then measure the overlap in citations between generated answers and expert answers. So these overlap metrics actually turned out to correlate quite well with human evals, but of course had the advantage of being fully automated. So this is the kind of creativity that can really help with real-world evals. So what were the results? We get approximately plus minus 50% and 95% win rate versus GPT-4 Turbo, which was at the time of this project state of the art. So that means that human experts prefer the outputs of the Harvey custom model about 95% of the time compared to baseline on prompts about case law. The expert citation overlap eval that I just mentioned also showed a 60% boost in F1 score. And it turns out the same citation overlap metric can be applied between different experts who have answered the same question, which allows you to assign a score to human experts and then enabled us to see approximately how much progress we had made between our baseline and between human experts. And turns out it's a good chunk of the way there. As a sidebar, I want to say how amazing I think it is that one can fine-tune GPT-4 on a corpus of specialized knowledge, and downstream of that, get generalization to complex, multifaceted questions about that domain. In this case, we trained GPT-4 on case law, and then after training, we find we can answer open-ended questions about case law by making reference to relevant cases that bear on that question. But it wasn't obvious to us from the outset that we would actually get such amazing generalization. And I think it goes to show what an extraordinary artifact a GPT-4 class model really is, that it can achieve such generalization. So lastly, I just want to note none of this would be possible without my excellent colleagues at OpenAI and also at Harvey. I'm done, but I'm more than happy to take questions.